A useful measure for a photographer when setting up their digital camera for a picture is the hyperfocal distance, capital D, which we can see in the formula just here. The photographer knows that every object at a distance greater than half of D from the camera will be in focus. In the formula above for the hyperfocal distance D, f is the focal length of the lens, n is the aperture number, and c is the diameter of the circle of confusion. All measurements must be in millimeters apart from the aperture number, which is just a number. Now we've got to calculate D in two different circumstances. Now in the first one we're given that f is 35, n is 8 and c is 0.019, and both of these are in the correct units. So D is going to be 35 squared divided by 8 multiplied by 0.019 and then add 35. So it's something we just need to put into the calculator. So use the fraction template, and then we've got 35 squared over 8 multiplied by 0.019, and then we've just got 3 squared there. Just got to be careful, always check what you put into the calculator. Plus 35 and execute, and that gives us 8094 to the nearest whole number. Then the diameter of the circular confusion is 0.023, so that's the value of C. The focal length of the lens is 135, so that's our value of f, and the aperture number is 5.6, so that is our n, and we want this one to the nearest meter. So D is going to be 135 squared over 5.6 multiplied by 0.023, and then we add 135. So we have 135 squared over 5.6 multiplied by 0.023, and then we're going to add on to that 135. So that's 141,633, and of course that's in millimeters, and we want this to the nearest meter, so it's going to be 141, this one's millimeters, 0.633 millimeters, nearest meter is 142. A photographer is using a lens with a focal length of 35, so that's our f, circle of confusion 0.03, and those are in millimeters, so that's all good. What aperture number should the photographer choose? So this is the value of n from the 8 available to ensure that objects greater than 1.3 meters from the camera are in focus. So D is going to be related to this. Remember that D needs to be in millimeters, but note that up here we're told that every object at a distance greater than half of D will be in focus. So what we need to do is we need to double D, or double this value here, so that if we use 2.6, then half of D will be the 1.3 required. And note that's in meters, so we need to convert to millimeters. So our value of D is going to be 2 times 1.3, that's in meters, and multiplied by 1,000 to put that into millimeters. So we've got 2 multiplied by 1.3 multiplied by 1,000 gives us 2,600. Substituting into the formula, 2,600 is equal to 35 squared. Now remember here we're trying to find n. So our C was 0.03, so that's 0.03 n, add 35, and we've got to solve that. Now we can solve on the calculator, we don't need to go through the process, so we can go Action Advanced Solve, and then we'll put the 2,600 equals, use a fraction template, so we've got 35 squared, and then on the bottom here 0.03, and to save fiddling around with the calculator just use x instead of n there, and then go add 35, and then we'll solve. So that says 15.9. Of course we don't have a 15.9, so I think the one that we need to choose is the one nearest to that, so we'll choose n equals 16.